Hello and welcome to another episode of James and Chris Science Videos, where today we're going to be looking at friction and some of the uses, what it is, when it's good, when it's bad, and some things we can do to eliminate friction if we really want to from a system. So let's start off with the question of what is friction? Well, friction is a force that occurs anytime two objects rub together and are going in opposite directions. So those surfaces can be solid, liquid, gas, and it's as it goes past each other, how it pushes over the bumps and crevices. Now I've included a picture here of a crate being moved, and you can see the magnified section at the bottom shows the kind of rough edges of when you pull it, how it's got to bump, push over and knock it over. So that's basically what friction is. And it's a force that can be useful and it can be a hindrance, depending on the situation. We're going to look at both types of examples in a minute. Little thing to notice is that the three main forms of friction we talk about are surface friction, which is really between solids, water resistance, which would be obviously in a liquid or a fluid, and air resistance, which would be in a gas. Those types of resistance also affect and are two substances rubbing together again, and it affects to slow down the object. Also useful to notice at this point that heat generally is a product of friction. When two things are doing, you can do it. You rub your hands together, you can feel your hands warming up, and that's the friction working as you're rubbing those hands together. So let's have a look. When friction is good is whenever you want things not to move and to slip. We tend to call situations that involve good friction, we tend to use the word grip. And so I'm sure if you sit and think for a second, all the places where grip is important, there's actually almost everywhere in your life. Imagine if you couldn't hold anything without it slipping out your hands, of how life would be. So friction as a force plays a huge part in our lives. Now I've included just 4 simple examples. The first of which is a shoe. So the grip on your shoe to stop you slipping uses friction. It uses that force to stick you to the ground. I've included a cricket mat where with the grip you want to make sure that the hand doesn't slip up and down the bat. Imagine you played a shot and the bat shot out of your hand every time. It'd be mayhem. Brakes are a clear example, so that's using friction to slow down cars. And again, the picture I've used highlights the heat that comes out of some of these brakes as they work. And in fact, this one's glowing as it does. And the last example comes from a documentary I was watching. They were talking about how they built the foundation for the Burj Khalifa, because real issue of trying to build foundations onto sand, because sand itself isn't stable. And so they use friction between different rods in order to stick it to the ground. And so the whole of the Burj Khalifa uses friction as its principle to keep the building still. And when used in large numbers, friction is a really large force. So why do gymnasts chalk their hands? So this is a case of increasing friction. Why do we bother? Well, chalk's going to do a couple of things. First of all, chalk's going to make your surface of your hand rougher. It's going to put ridges on, which is again going to stop things sliding over your hand. But also it's going to eliminate any water. And we're going to talk about water and lubrication, of how that works and how that makes things slippier. So we're going to look at that in just a second. So, little task for you to do. Here is a practical that I would like you to think about and probably write down, and if you're in one of my lessons, if you could send it to me via the OneNote that I've set up. But here we've got a block with 4 different surfaces. The 4 different surfaces are plastic, carpet, sandpaper and wood. And I want you to imagine that you've got a wooden block about so big, and on it you've got a hook. So there's kind of like a picture of those little kind of wooden blocks there. Now, the other bit you've got is a force meter, which is a spring and a hook. And when you pull things along, the spring extends, and that extension will tell you the force. So what I want you to do, I want you to pause the video at this point. I want you to come up with and write a plan for how you would investigate which surface out of plastic, carpet, sandpaper and wood, of which one of those would give us the greatest amount of friction. Think about how you're going to keep your independent variable, the dependent variable and the control variables clear. How are you going to make sure that you're going to keep it a fair test? How are you going to make sure the test is reliable? So pause the video, get that done, and once you've done that, come back onto the video and press play. So we've done when friction is good, when grip is good. So there are times when friction is bad, where we don't want friction to happen, where we want things to slide over each other easily. So again, I've just given here 4 quick examples. The first is an engine. The parts in an engine are moving quickly all the time. And if they rub together, the heat that you'd get would be too much. It would cause damage to the engine. So in order to eliminate that friction, you put oil in your car, and that will help it move. The other I've got is a speed skier, of how they make themselves smoother through the air, but also their skis, of what they've got to do with their skis in order to make sure that that goes over the slow quickly enough. I've included an aeroplane, so you don't want anything to hold that back, no air resistance. You want as little as air resistance as possible so that its fuel use will be less. And then I've put a non-stick pan where you don't want the eggs, once you cook them, to stick to the bottom. So I want to eliminate friction. So how can you get rid of friction? Well, the first of which is lubrication. Now, lubrication is using a liquid across a surface in order to make it go smoother. So in this picture here, you've got the idea. Now, with a solid, at microscopic level, the surface is not flat. There are bumps and ridges. Now, if there are bumps and ridges, and I pour a liquid into it, the liquid fills up the holes and comes up just to the surface. So it actually creates a flat surface. And if I go beyond that, it completes a completely smooth surface because it's lifted them apart. The 2 sections aren't actually touching, they're just running along the liquid. Remember, the particles in the liquid are free to move. There's nothing holding them together. So lubrication works in that kind of way. You need a liquid to fill in the gaps, then it goes over. Imagine, by the way, if we put a liquid in like water and then it freezes, then that becomes even smoother because the water level itself, when it freezes, that is pretty much perfectly flat, which is why ice is so slippy. So the second thing we can do, is particularly for air resistance, is we can improve, or water resistance, is the aerodynamics, the streamlining, making sure the space, the object, is as smooth as possible and as rounded as possible so that the air can pass directly over it rather than hitting direct. So here is an example of different objects and how the air can go around it. So let's summarise quickly. Friction is a force. It happens whenever 2 surfaces rub together. It can be good or bad, depending on what you want it for. We can use force meters to measure friction because it's a force. And that if you want to get rid of friction, we would use streamlining and lubrication. Thank you very much for listening. Hope to see you again soon.